Hello, this is Justin Fischetti. Today I'm going to go over a few what the Pythagorean Theorem is, what it's used for, and we'll go over a few examples. So first, the Pythagorean Theorem is a theorem that shows the relationships between the three sides, the lengths of a right triangle, meaning one of its angles is exactly 9 degrees, as depicted here. As depicted here. Now so you have the three sides, the lengths of three sides here labeled with variables. This is A, this is B, and this is C. C is called the hypotenuse, and it's always the large hypotenuse. Sorry to word jump fast. This is hypotenuse. It's always larger than the two other sides, and these two other sides are just called the legs. They'll always be shorter than the hypotenuse. So they can each be A and B are not necessarily the same though, but C is always going to be larger than both of them, regardless of what A and B are compared to each other. So this is the relationship on how that the theorem depicts. The length of A squared, plus the length of B squared, and equals the length of C squared. And I'll show you how it works with probably the simplest. Here, I'm going to show this the triangle, it's a right triangle. I'll use I'm going to show just some instances to show how it works with this 3, 4, 5 triangle, right triangle is the most simplest way to show this. So you have, so remember, it's the formula, the Pythagorean theorem was A squared plus B squared equals C squared. A, we said is 3. We'll leave the squared there because the lengths are not. This 3 is not A squared. 3 is just A on its own. And same thing with the 4 there. We put in place of B, so that'll be 4 and squared there equals C, and C is 5, so 5 squared. Solve out the squares. 3 squared is 9, plus 4 squared is 16, equals 5 squared, which is 25. From here, you can simple math, 9 plus 16 is 25. So 25 equals 25, therefore proving that the Pythagorean theorem works. Now, often you'll have problems where one of the sides is missing, either the hypotenuse is missing, or one of the legs, either A or B, is missing. In that case, we'll go over, let's say, I'll clear this. Say we have that 3, 4, 5. That triangle. So you have a 3, 4, 5 triangle again, but you don't know we don't know what the hypotenuse length is. So here's how so basically we just plug it into the Pythagorean theorem. So this is A, this is B, but C is missing. Formula against A squared plus B squared equals C squared. Plug in the A and B directly, so 3 squared plus 4 squared equals C. So plug in the C, but leave it as C squared. And then solve this out. Solve out the squares, so you got 9 plus 16 equals C squared. And then you have 25, divide these two together, 9, 16 equals C squared. Then all you have to do is just solve C squared equals 25. In order to get rid of this square, you have to take the square root of both sides. So just take the square root of 25. Square root of 25 is 5. So 5 equals C. Therefore, you can solve for that. And similarly, if you have the hypotenuse, but you're missing one of the legs, 5, 3, and you're missing A here. Again, just write down the formula, A squared plus B squared equals C squared. That the hypotenuse, which is always the one, which is always just the angle of side, is 5. and the other leg is, which we call the missing one a, so this will be b. So it'll be a squared plus 3 squared equals 5 squared. Now again, solve out the squares. So it's a squared plus 9 equals 25. Now, in order, you want to get the a squared by itself. So subtract 9 from both sides. So a squared minus 9 equals 16. So now you have a squared equals 16 left, and you want to take the square of both sides in order to cancel out the square on the a. So you have a equals 4. Therefore, we solved it. So that's pretty much how you do it in the most simplest terms. We'll do like 2 examples of each from different website, different ones from the 3, 4, 5, a little more complex. So I'm going to switch the screen to this. And let's solve it. This we'll do 2 again. We'll do 2 of these with the hypotenuse. So we see where C hypotenuse is missing C. So a can always write down formula a squared plus b squared equals c squared. So C is missing. We'll call this A and this B. So 5 squared plus 12 squared. 12 squared equals c squared. Now you just have to know what these numbers squared are. So 25 squared is 25. 12 squared is 144 equals c squared. Add 25 plus 144, that's 169. That equals c squared. Now, as you're doing the key overall is that you need to know what the simpler numbers, like say 1 through 15, are both squared and the square root of them. In this case, you need to know the square root of 169 to cancel out the that squared on the c. And then here, if you take the square root of 169, that will give you c equals 13. And well, actually, too, one thing too, there's units here, miles. Make sure you always remember the units as well. If they're given, I did like the example I did with the 3, 4, 5 triangle. I didn't have any units, but you also will be asked for units. So let me let's confirm 13 is the answer here. Nice. All right, let's do this example. And I always like to write down the formula just to know that we have it here, so you can directly plug it in. We're missing hypotenuse again, so again we'll call this 12 meter A, 9 meters B. So 12 squared plus 9 squared equals c squared. So 12 squared is 144 plus 9 squared is 81 equals c squared. Now you know 144 plus 81, that's, when you figure that out, that would be 225 equals c squared. And then you have to take the square root of both sides. So you need to know what the square root of 225 is. I believe, I'm going to check make sure I don't make embarrassing mistake, but I believe that's 200. I believe that's 15. Make sure you know how to do this. Yes, it is 15. Just didn't want to make an embarrassing mistake by typing in the wrong answer there, but a 2 square root of 225 is 15. So C equals 15 and meters. So make sure you have the M for the units we're given in meters. All right, that's all for the hypotenuse. We'll also do like 2 examples here where we're finding the missing, we are given the hypotenuse, now we're finding the missing leg length. So gap and annotations will clear this. Write down the formula. So we're missing so as you know, the side that's the diagonal side of the one and the side is always opposite of the right angle, which is shown there is always the hypotenuse, that we see. And B is a missing one, so we'll just call the other one A. So now we just got to plug these two in. A is 12 squared. We're not given B, so we'll leave that as B squared equals 13 squared hypotenuse. So you know 112 squared is 144. So B squared we'll leave here equals 13 squared is 169. Now you have to subtract 144 for both sides. And that's just cancels out the 144 on the left side, so we'll just have the B squared equals 169 minus 144. Do the math here. Actually, the way just what you just subtract downwards. That's just 5 2's 25, and then you got to take square root of both sides. This one's pretty simple. No, this is just square root of 25 is 5. So we'll, and it's units distance in millimeters, so I'm 2 m's, 5 millimeters. All right, and this will be the last overall example that we'll do. Again, we're given hypotenuse opposite the right angle and the diagonal side. That's 10, and we're missing B, so this other leg must be A. So plug them in. A is 6, so 6 squared. You don't have to B, that's B squared equals the hypotenuse is 10, that'd be 10 squared. And then just solve these out, 36. So square roots out, 36 for 6 squared plus B squared equals 10 squared, which is 100. And then, subtract 36 from both sides. So you can get the B squared by itself. So B squared equals 100 minus 36. That should be 64 if you do the subtraction. So B squared equals 64. Take square root of both sides, and you'll have B equals 8, and this time you insert in centimeters. So let's confirm that that's correct. Nice. Okay. So that's hope you now kind of get the gist of what you do. It's the same process whenever you want to do it, and whenever you're getting hypotenuse, you want to find one of the missing 2 legs, your A or B. In this case, actually, they gave us B, and we're trying to find A, but it's really the exact same process, except you just plug in an actual number for B, and you're just solving, and you subtract the B squared over on the hypotenuse side, so you get the A squared by self-solve, right? Same exact process. And the hypotenuse went over that, just plug in A squared and B squared, and then just solve for C squared by adding these two together and taking the square root of that result. So that's all for this. Learn about the Pythagorean theorem. I hope this helped, and thank you. Have a good day.